I am so glad you're here because today we're going to learn about balancing chemical equations. You see, chemical reactions must obey the law of conservation of mass, and this means that atoms can't just appear and disappear. And so we balance chemical equations to ensure that each element of each chemical appears in both the reactants and the products of chemical equations. We can actually break down this process of balancing chemical equations into 5 easy steps. Step 1 is to begin by writing the correct formulas for the reactants and the products. So let's say, for example, we're looking at a situation where hydrogen gas, or H2, is reacting with oxygen, or O2, to make water. And water has a chemical formula of H2O. Step 2 for balancing chemical equations is to then count the total number of atoms for each molecule on both the reactants and the products. So if we start by looking at the reactant side of our chemical equation, which is to the left of this reaction arrow, then we can see that on the reactant side, there are 2 hydrogens and there are 2 oxygens. And that's what those subscripts are indicating, that there are 2 hydrogens and 2 oxygens. For the product side, which lies to the right of this reaction arrow, we see that there are 2 hydrogens. However, what you should notice is that oxygen doesn't have a subscript, which means that there's only 1. So there's 1 oxygen on the product side. So then we can move to step 3 of our easy steps for balancing chemical equations, and that's to use coefficients. And what I mean by that is just like in algebra, when you use a coefficient, you multiply that entire molecule by whatever the coefficient is. So let's say, for example, that we place a 2 in front of this H2O. If we were to place the coefficient of 2, that means that we need to multiply this entire water molecule, or H2O, by 2. So what we'll do is multiply 2 H's by 2, which will give us a total of 4 H's. And if we multiply 1 oxygen by 2, that will give us 2 oxygen. So now if we come back over to the reactant side, I see that I need to balance 2 hydrogens to 4 hydrogens. And again, I can do that by using the coefficient. So if I place a 2 in front of H2, this means that I will multiply this value by 2 and end up with 4 hydrogens. Notice then that this matches both the reactant side and the product side. And also, I don't actually need to do anything to oxygen since there were already 2 oxygens on the left-hand side, and now that I have multiplied H2O by 2, I now have 2 oxygens on the product side. And this means that I now have a balanced chemical equation. Now, before I give you the last 2 steps for balancing chemical equations, make sure you stick around to the end because I'll give you a practice problem that should help for your next exam. The 4th step is actually that you should wait to calculate the number of hydrogens and oxygens for last. So wait to count the number of hydrogens and oxygens for last. This is typically going to set you on a good direction when balancing chemical equations. So let's try another example. In this example, we're going to be looking at the combination of iron, which is a metal, combining with oxygen gas, which is O2. And this is going to generate a product known as iron oxide, which has 2 irons and 3 oxygens, or Fe2O3. And this is the correct formula for iron oxide, the correct formula for iron, and the correct formula for oxygen gas. So we've completed step 1. Next, we need to calculate the atoms for each element on the reactant side and the product side. On the reactant side, I see that there is 1 iron and there are 2 oxygen atoms. On the product side, however, we actually have 2 irons because it's Fe2, and I have 3 oxygens because it's O3. So there are 3 oxygens on the product side. And what you should notice is that there's an odd number of atoms of oxygen on the product side. And one quick little tip is that if you start by looking first for even numbers, this might be helpful. So for example, we can turn that 3, which is an odd number, into an even number if we count 6 as the number of atoms. And in order to make oxygen be 6, I need to multiply 2 times 3. So 2 times 3 will get us to 6. So that means that if we multiply those 3 oxygens by 2, we end up with 6 oxygens on the product side. And similarly, since we place this 2 as our coefficient in front of this molecule, we need to also multiply 2 times the number of iron atoms. So in this case, 2 times 2 is going to equal 4 Fe, which stands for iron. And now when shifting over to the reactant side, I need to look at iron and figure out how to make there be 4 irons oxygens on the reactant side. And in order to achieve that, I just need to place the coefficient of 4 in front of that atom in order to give us a total of 4 irons on the reactant side, which will match the number on the product side. And then in order to turn the reactant side oxygen into 6 oxygens, I know that I can place a coefficient of 3, which means that I will multiply 3 times 2, which is how I end up with 6 oxygen atoms on the reactant side. And that leads us to step 5, which is just to check your work. So in order to make sure that you have the right answer, you always want to check. So I will go through and see that 4 times 1 is equal to 4 irons. 3 times 2 is equal to 6 oxygens, and that gives us the amount of atoms on the reactant side. Shifting back to the products, I see that 2 times 2 for iron is equal to 4 irons, so that one matches. And then 2 times 3 for oxygen gives us a total of 6 oxygens. And this means that this is a balanced chemical equation. Now it's your turn. Pause the video and try this problem independently, and then resume the video to check your answers. In this reaction, we're looking at the combustion of propane. Combustion reactions are always the result of taking a hydrocarbon, oxygen gas, igniting it with some sort of flame, and generating CO2 and water, or carbon dioxide and H2O. And these are the chemical formulas correctly written out for each element on both the reactant and the product side. So we've completed step 1. For step 2, we need to count the total number of atoms for each molecule on both the reactant side and the product side. For this case, on the reactant side, I have 3 carbon atoms, which is indicated by the subscript 3 right next to carbon. For hydrogen, which is our next element on this molecule, I see that there are 8 total hydrogens, which is indicated by the subscript 8. And then oxygen is our last remaining element, in which case there are 2 indicated by the subscript 2. Next, I need to shift over to the product side, which is to the right of this reaction arrow, and I can count that there is only 1 carbon on the product side. There are 2 oxygens located in CO2, but also remember there's an oxygen on H2O. And if I add 2 plus 1 together, that will let me know that there are a total of 3 oxygen atoms on the product side. Next, I can count that there are 2 hydrogen atoms, and that gives us our total for both the reactants and the products. This means that we have completed step 2. The next thing that I'm going to do is use coefficients to try to balance these out. And remember, those coefficients should be multiplied throughout the molecule. Importantly though, step 4 tells me that I should wait to do hydrogens and oxygens last. And since our only other element is carbon, that's where I'm going to begin. So on the reactant side, I see that there are 3 carbon atoms. And on the product side, there's only 1. So what I can do is actually place a coefficient of 3 in front of CO2 and then multiply throughout to end up getting 3 carbons. But notice that this has also changed the number of oxygen atoms because that 3 coefficient has to be distributed throughout the entire CO2 molecule. So for that reason, I need to multiply this value by 3. So 3 times 2 is 6. Plus I have 1 more oxygen, so that gives me a total of 7. So I no longer have 3 oxygens, instead I have 3 times 2, which is 6, plus 1 is equal to 7. So there are 7 oxygens now on the product side. And now that I have balanced the total number of carbons on the reactants and the products, now I can go and start to work on the number of hydrogens and oxygens. And I'll begin with hydrogen. On the reactant side, there are 8 total hydrogen atoms. However, on the product side, there are only 2, and both of those come from H2O or water. And in order to get to 8, I can place the number 4 in front of H2O, indicating that I'll multiply 4 times 2 in order to get a total of 8 hydrogen atoms now on the product side. And notice that that means that I have the same number of hydrogens on the reactant side and the product side. However, don't forget, because we placed that 4 in front of H2O, this means that we have to multiply the number of oxygen atoms by 4 as well. So remember, on CO2, we had 3 times 2, which is 6, and now we have 4 times 1, which is 4. And if I add 6 plus 4, I get a total of 10 oxygen atoms on the product side. Now all I need to do, since I've matched the total number of carbons and hydrogens on the reactants and the product side, now I need to work on oxygen because I have 10 total oxygen atoms on the product side. And in order to achieve that, I see that O2 contains 2 oxygen atoms, and if I place the number 5 in front of that, that means that I will multiply 5 times 2 in order to get a total of 10 oxygen atoms. And now each of these elements match where I have 3 carbons on reactants and products, I have 8 hydrogen on both the reactants and the products, and now I have completed 10 oxygens on the reactant side and 10 oxygens on the product side. And that means that we have completed all of the steps for balancing chemical equations. If you check the description, I have thousands of practice problems that you can check out to help you ace your chemistry class. Drop a comment down below if you have any questions related to chemistry, and make sure that you subscribe to the channel so that you never miss out on another video. I'll see you next time.